Hi, my name's Kate Haro. I'm a chemistry teacher at Lake Forest High School in Lake Forest, Illinois.
And I'm Brad Gorel, a chemistry teacher at New Trier High School in Winnetka, Illinois. We're co-authors of the food packaging module. Consider this an invitation to explore the possibilities that this module might have in your curriculum. One of the great strengths of the module is its flexibility. It can be adapted to students at several different ability levels and to a wide range of age groups, from middle school to high school. The module is an effective way to support student-centered teaching strategies. The flexibility of the curriculum allows for the natural implementation of inquiry-based learning, problem-based learning, and design technology. Teachers can adapt the materials depending upon their own inclinations and needs to take either a more qualitative or quantitative approach.
That's quite true. Another side to this module is the consideration that students get about the environment. One of the things that happens, or seems to happen to most of our students, is they become personally invested in the decisions they make about what food packaging to choose when they're buying their own food and snacks in the supermarket. And one thing that comes out of this work that we've done is that there are always dilemmas inherent in environmental considerations and environmental issues. And the choices that students make tends to give them a sense of empowerment and that their decisions have an ecological impact. One great activity that we do is the hook. All of the modules have a hook, and ours is no exception. We use packaging material that the children choose of a particular theme. Maybe in this case we've used apple juice containers. And the apple juice containers can be made out of plastic or tin or any composite materials. The students go and buy them, bring them back to the classroom, and do a presentation. What happens through this activity is their awareness of the different types of materials available to them, that they have the choice of what type of material they're going to use.
The national standards are of increasing concern to teachers, and this module provides a way to meet standards that are often neglected by many curricula at the middle and high school levels. The food packaging module lends itself quite naturally to the examination of how material science has impacted our society, culture, and history. Oral presentations are also easily built into the curriculum, and very significantly, the interdisciplinary nature of science becomes more clear to students after studying this module.
That's right. Another aspect of this module is its use as a research project or classroom debate. What we have done in the past is we have used paper versus plastic as a basis for a wonderful classroom debate. The children have been able to use the modules themselves to do research on all the background information about how the materials are produced, what the resource management of these particular materials are, and how landfill considerations can be taken into effect. All of these go together to make a really good debate in the classroom. One of the most exciting design projects that the students encounter in this module is the tomato drop experiment. It's their first experience with problem-based learning. What they have to solve is the problem of getting the tomato from the farmer to the home. And they use the real thing, tomatoes. A lot of flexibility is possible. There are infinite ways in which to develop the problem here, and ways to define the parameters within which to work. Each teacher can adapt the lesson to emphasize his or her own teaching points. The lesson leads very well into a contest format. The ultimate goal may be that the package may protect a tomato being dropped from a height of about 2 meters. The constraints placed upon the designers will most likely demand some type of compromise between the cost of materials and the environmental friendliness of the packaging. It's up to the students to assess the value of each decision they incorporate into their design. Designers are given the opportunity to test and modify their final products before their presentations. This helps develop teamwork, communication, metacognitive skills. The task itself also helps students understand and appreciate how scientists and manufacturers must make real-life choices. Solving the problem can take a few days, But by the end of this design project, students will have developed a greater awareness of the tensions associated with many scientific endeavors.
The design problems in this module involve finding or building a desirable package for a food product. One of the projects is quite open-ended, and one is slightly more prescribed. Both allow for collaborative work among the students, where the roles of students are differentiated within their group. When each student has the freedom of choosing his or her particular task, the group work can often be outstanding. Students can be instructed to work efficiently in parallel on their various tasks in the design projects. Such teamwork proves to be both productive and fun. The task is to persuade the hypothetical owner of a fast food restaurant to adopt a particular packaging design. The major roles of the students could include experimentation, analysis of data, library and/or internet research, keeping a learning log, and writing a final report. Numerous design requirements are possible. These could include dealing with the insulating capacity of the package in the wintertime when the hot fast food is delivered by bicycle, evaluating the protective capability of the package, determining its cost, and researching its environmental ramifications. Students can also be required to redesign their packages after critiquing their first designs. The final reports should be evaluated based upon how well the students support their arguments from their experiments, their mathematical analysis, and their research in the literature. As an option for more advanced students, or at the discretion of the teacher, this particular module has a mathematical modeling component, which is carried out computationally using one of several popular environments, such as spreadsheets, an assortment of TI calculators, or the visual modeling environment called Stella. Students build a computer model of the cooling behavior of hot food in various packaging designs at various air temperatures. This allows accurate and specific analysis of how the hot food will behave under different scenarios that are of interest to the students. Including this component within the chosen design project will add a substantial mathematical and technological emphasis to the curriculum, one that is receiving significant attention in the literature.
All of these resources are available on this website. Now, go have some fun with your students.